Um, Hello, everyone. Welcome to our second colloquium of the semester. I'm moderating today, but as usual, let's thank our colloquium organizers, Young, SK, and Ben for putting all this together. And this is a bit of a different format than we were originally planned, but we are really excited to be able to do this and so to have Dr. Andres Buxo-Lugo with us today. So Andres is an assistant professor of psychology at the University of Buffalo, where he leads the language processing and computation lab. Before joining the University of Buffalo, Andres obtained a PhD in psychology from the University of Illinois at Urbana-Champaign, and he was then a postdoctoral scholar at the University of Rochester and at the University of Maryland before getting to Buffalo. So Andres is broadly interested in what speech and prosody reveal about the cognitive mechanisms that underlie language production, comprehension, and acquisition. He has published in journals like Cognition, the Journal of Language and Memory and Language, the Journal of Experimental Psychology, and his recent research focused on how listeners integrate information from a variety of cues and how people learn to understand and produce constructions that are not already familiar to them. So, for example, new uses of prosody, pronunciation that are not native in their native language, etc. He's also recently been interested in developing computational models to explore some of these questions. As a personal anecdote, any student that has been in my classes knows that I enjoy sprinkling examples from my favorite TV shows and cartoons. And my first professional memory of Andres is actually as what's now called as the Human Sentence Processing Conference, where he had this beautiful talk about prosody, but where he had he started with this example with a short video from Steven Universe, which is a cartoon that I love, and I got immediately excited. So this is really my first memory of you at the conference, Andres, which is cool.
Yeah.
And that's it. Join me in welcoming Andres with us, and let's hear what you can tell us about suprasegmental cues as a window into prosody. And you can go ahead.
Yeah. Wonderful. Well, thank you so much for having me here and for inviting me. Uh, it's too bad that I faced some challenges in joining you in person, and I'd really like to say that that the talk is going to be worth the wait and all the hassle. But I don't feel super confident about that, but I will do my best. And so today I'm going to be presenting some of my recent research. And really, I'll admit that the framing is a little bit of a way of kind of trying to, or an attempt, let's say, of joining these somewhat disparate lines of research. But I think there is something that kind of connects them underneath, right? And so what I'll be presenting today is research that, broadly speaking, kind of goes into looking at how we say something and how that can provide important information about language production processes, right? So the kind of shape, so to speak, that we give our message can give us some important clues or kind of serve as a window as to what's going on in our minds when we try to turn that abstract message into the sounds that that a listener can then hear and hopefully get to our intended message. Right? Within this, I'm going to be talking about two kind of separate phenomena, or maybe not so separate, depending on on how you think about it. But I'm going to be looking at prosody, so things like the intonation, intensity, and rhythm of speech, and the type of information that is often conveyed through that. But also word durations in a maybe a more implicit or maybe a more subtle way. So kind of modulations and word durations that often come about as kind of artifacts of the language production process, right? So when do people kind of slow down or lengthen words? When do people speed up or kind of say words more quickly? And what does that tell us about what's going on in our minds when we're speaking? Um, so another way of putting this is kind of following up on this question of what can we learn about language production processes from what our utterances sound like? And that's, I think, a kind of one motivation to some of my research. So for this talk, I'll be first talking about one study that uses production priming to learn about how prosody is represented in the mind, at least some first steps in that direction. And that's going to be a behavioral experiment. It's a simple one with some recent results that I'm excited to show you. And then I'm going to kind of switch gears and talk about a separate set of studies that attempt to use word durations to learn about the process of phonological encoding. So this process of assigning a form to our message. And I'm gonna quickly review some past studies, but the part that I'm most excited about is to show you a kind of very simple computational model that makes some, I think, pretty interesting predictions that we're currently testing. Oh, I should mention, I guess before I go into the meat of the talk, if there's ever any questions or any clarifications that I can provide, I'm happy to be interrupted in whichever way. I can see the chat, or you can, just unmute and start talking, and I'm happy to address. All right. So the first of these studies is looking into prosodic encoding. So this question of how do speakers assign the appropriate prosodic phenomena to their utterances and then, shape their utterance accordingly. There's of course been a lot of research into prosody. There's a lot of theory, a lot of behavioral work that has shed light into what kind of information we communicate, what cues we use. But I think it's been difficult to kind of learn about the cognitive processes that are in charge of this, right? For some reason, prosody seems somewhat mysterious, whereas there's a lot of theories of language production at the whether syntactic or about like lexical selection, etc. For prosody, it's been a little bit nebulous, and so I've been really interested in learning more about it. How can we learn about this process of prosodic encoding? What is the process and what are the relevant representations, right? It's not to say that we don't know anything about it, but kind of probing those representations, learning about them can get tricky to the point that sometimes there's questions about, well, are these proposed types of accents different from each other, or to a speaker's mind, are they underlyingly the same and it's just different contexts that seem to make it appear like they're different, etc. Right? So it'd be nice to find a way where we can kind of ask those questions. Now, when looking at other levels of linguistic representation and how psycholinguistics and linguistics have explored these questions for other aspects of linguistic representation, we see that there's been a ton of priming studies, right? Just a classic methodology and pattern that can be really informative, right? And so priming itself is very general. It, by definition, it's just when exposure to a stimulus affects a subsequent behavior, which of course can be applied to just about everything. And of course, it's been applied within psycholinguistics too. So priming studies and priming results have shed light on how people represent, for example, semantics or like the meaning of words and how different words may be related to each other because of semantic associations. There's phonological priming that has shed similar light on how we represent words and sounds. For the context of this talk, I think the most relevant studies, because it's kind of what I used to model my own study, is studies on syntactic priming, right? So these are studies where um, participants are exposed to some kind of syntactic structure. Maybe they hear a sentence that has a certain syntactic structure. And then when they produce a sentence, it's more likely to kind of match the same structure that they heard than if they were to produce that sentence without having heard that, right? And so this is by now a kind of classic study slash effect, right? Bach, 1986, reported this pattern. And um, at least some of the context as it was explained to me when I first learned about it back in grad school was that this was really compelling evidence that there was some kind of psychological reality to some form of syntactic representation that could be separated from uh, lexical content and other aspects, right? That you can kind of activate a syntactic structure and then that's going to affect people's behaviors. They're going to be more likely to kind of structure things in the same way, even if there's no shared words or anything like that. And of course, there's been a lot of studies following up on that. So I limited the citations to two here, the original one, and then this big meta-analysis that looked at a bunch of other syntactic priming studies with a lot of different variations. And you can kind of see patterns that that I think shed important light. You can start asking more nuanced questions about uh, how people represent sentence structure. For example, what happens if someone says a sentence that you think is very unlikely? Do you still activate like the structure that you heard, or do you activate the more likely structure that you kind of infer, right? Etc. Right? That's just a selfish example because I have a study that did that. um, so what about prosodic priming, right? Has anyone looked into it? Is there evidence for it? And so far, at least as far as I'm aware, there's been mixed evidence on whether prosodic priming uh, occurs or whether prosodic representations can be primed. Um, there's a couple of studies that have found evidence for, um, specifically these studies by June and Bishop, where in their studies they um, expose participants to sentences that had intonational boundaries at specific locations. And then the listeners had to read a sentence silently. And they found that depending on where those intonational boundaries were in exposure, it affected how people disambiguated or resolved these ambiguous sentences when they read them silently, right? And so some evidence for some priming, in this case, relying on this implicit prosody hypothesis, right? This idea that um, when we read, even if we're reading silently, we're imposing a prosodic structure to that sentence, right? Um, Nevertheless, I do think there's some room for exploration here because it's in this very specific context, and I think if I'm remembering correctly, there were some um, it seemed like a very sensitive effect where maybe you needed multiple exposures before each reading in order to kind of observe the effect. So it'd be good to find some more evidence, I think. At the same time, there's been uh, some evidence against uh, the presence of prosodic priming. So specifically these two papers from Tooley, Konopka, and Watson that tried doing a kind of prosodic priming study that's very analogous to the syntactic priming studies that I mentioned before. And they ran multiple experiments looking at different prosodic phenomena, and they found no evidence that at least linguistic prosodic phenomena could be primed. So they looked at focus, they looked at intonational boundaries, and at least in their studies, whether or not people had been exposed to these phenomena, then when they produced their own sentences, they didn't find that people were now more likely to kind of match the prosody. Right? They did find some evidence that speech rate could be primed. So if you hear someone speaking fast, you may be more likely to kind of speak faster. If you hear someone speaking slow, you may be more likely to speak slower. But in terms of these more kind of traditionally linguistic representations, they found no evidence for it. So I've been interested in following up on this. Firstly, because there haven't been that many studies, and I have some ideas as to maybe what may be going on. More on that in a bit. But also because I think the implications would be really interesting. So is it true that prosodic productions can't be primed? And if not, like, what does that mean, right, about how we represent prosody? Like, is prosody really that different from just about everything else that we observe in language? Um, does it mean that prosody doesn't really have these abstract mental representations, or at least that they can't be kind of separated from other aspects like lexical content or something like that? Um, is it that maybe prosody works like everything else, but the priming effect is not detectable? Like maybe prosody is so flexible that it just kind of, whatever priming effect fades between exposure and production, which maybe it's possible, but then we may have no way of detecting it. And then methodologically, we may not be able to ask those cool questions that we were hoping to ask. So for this study, I had a hypothesis, which is that some of the previous studies that tried exploring this didn't find evidence for prosodic priming because there was not enough of a supportive context to observe the, the priming, right? And so part of why I think this is because, for example, in those Tooley et al. Studies, this is not to dig on them. These are my friends, but the in this case, people heard primes like this. So the Mexican billionaire purchased a photo of the landscape at the auction, where there may have been words that got focus or receive some sort of prosodic accent. And then people have to produce a sentence like the professor assigned a book about the Greeks to the class, and they saw whether hearing the prosodic focus made it more likely that people would include it in their utterance. And it's a possibility. So I think it's informative that they don't find priming effects. I'll talk more about that in a bit. But here, there's not really much context about the professor or about the book or about the Greeks, etc. And so like maybe what's happening is that in order to prime prosody, you kind of need to do it at the message level, right? You kind of need to have enough of a reason to want to convey that information, whereas in this case, it's kind of not there. So maybe it's expecting a little bit too much out of priming in shaping our message. So for our experiment, we were looking into, again, very first step, so not the most nuanced question, but we want to know, can the production of contrastive accents be primed? So in this case, for this study, we're looking at contrastive accents. I think it makes a nice example to start with, right? They're fairly easily detectable. Um, I think people have good intuitions about what they mean. It's not too hard to create a context that would license it. Um, and it's, at least, I don't know how accurate this is, but it seems intuitive to think about priming a contrastive accent, right? Where, well, if you are exposed to a contrastive accent, maybe that kind of makes it more accessible or something, more likely that you may want to include that information as well. The study, as I've hinted, is inspired by the classic syntactic priming experiments. So there's an exposure phase in which participants are going to hear recorded sentences that may or may not contain a contrastive accent. And there's a production phase following the exposure phase where participants produce a sentence where it is optional to include a contrastive accent. So the part of the goal is for it to be natural to include a contrastive accent, but it's not necessarily mandatory, so that we have the wiggle room where we could observe some sort of priming effect. Given that in this case we're interested in contrastive accents, each of these phases is composed of two sentences. The first sentence is kind of there to provide a context, and then the second one is there with the kind of critical information, but the first sentence is there so that a contrastive accent would be felicitous. So I'll show you roughly what the study looks like, right? It's a very simple task. We do this in the lab, and this is a kind of PowerPoint recreation of it that doesn't look very different from it. So as a participant, you would be in front of a computer. You'd see a display like this where you have different colored shapes. And for the first phase, you hear some simple instructions that you're expected to follow. So you may hear a recording that sounds like this.
Click on the blue star.
Okay. And hopefully some audio went through that said click on the blue star. And as a participant, all you have to do is literally click on the blue star. So pretty simple, but of course, given that you have to do something, there's some motivation to be listening at least. Once you click, you hear a second instruction, and it may sound something like this.
Click on the red star.
So click on the red star in this case, right? And all people have to do is click on that shape, right? Once they do that, after the second instruction, they see a new display with different shapes. And now one of the shapes flashes on the screen, kind of like so. After that, they hear a beep. The beep is just an instruction that, oh, now you're being recorded, you can start speaking. And people are now expected to produce an instruction out loud that would tell someone to click on the shape that flashed, right? So if they saw the purple cloud flash, they'd say something like, click on the purple cloud. Once they're done, they can press a key for the next thing to happen. Then a second thing is going to flash. They'll wait for the beep and then say something like, click on the yellow cloud. Right? So that's one trial. And so then the whole thing repeats with different shapes and different recordings, etc. So as for our design and our manipulations, it's a 2x2 design. So we have a prime manipulation, which is getting at whether the participant heard a contrastive accent before they had to produce their own instructions, right? So for example, in the prime condition, the first instruction they may hear is click on the blue star, and then the second instruction may be something like click on the red star, right? Just as you heard a little bit ago. In the no prime condition, they may hear something like click on the blue square, click on the red star, right? In this case, we didn't mess around with whether the contrastive accent was felicitous or not. We kind of kept it pretty simple. So every time that that people were in the prime condition where they did hear a contrastive accent, it was felicitous to do so. So we haven't gotten into messy areas where, well, what if you hear a contrastive accent, but it wasn't licensed, etc. Not yet, at least. Okay. We also have a context manipulation, which is about whether the context from the speaker's perspective licenses the production of a contrastive accent. And really, this is more about the first instruction that the speakers need to produce, whether it kind of makes it make sense to include a contrastive accent on the second. So we have a modifier focus context where people may say, click on the purple cloud, then click on the yellow cloud, right? Where it's pretty natural to put that contrastive accent on the modifier yellow, right? Because cloud was the same shape for the first instruction and for the second instruction. compared to what I call a neutral context, where the shapes are different. And so they may say something like, click on the purple heart, click on the yellow cloud, where now if they just had click on the purple heart, click on the yellow cloud, it'd be a little bit awkward because the shapes are different. So why are you accenting the different colors in this case? Okay, so that's the study. We ran this, we collected data from 35 English speakers. These were students at the University of Buffalo. And each one of them did this for 60 trials each. So it doesn't take that long, but it's tedious, as you may imagine. Minus some data loss due to some technical difficulties. We did this in PsychoPy, where sometimes the recording with PsychoPy kind of crashed, so we did lose a little bit of data. Also, it's a production study, so sometimes there's speech errors or disfluencies and things like that that we kind of had to throw out. But nevertheless, at the end, we ended up with 1,826 productions of the critical sentences. And we're interested in whether and how often people produce these contrastive accents in these sentences and how that varied between the conditions. Now, the results I'll show you are pretty high level in terms of how we decided whether the speakers produce these contrastive accents. So I'll be showing you some judgments, kind of impressionistic judgments, where two raters listened to all the recordings and reported whether they heard a contrastive accent on the modifier or not. Right? So these are pretty, what I'd call impressionistic judgments. We've been doing acoustic analyses as well. I don't have these for this talk, but I'm happy to tell you what I'm finding if you have questions. The raters were blind to the condition, so they didn't know what condition each recording came from, and they didn't hear the first instruction that the speaker gave. So for example, if they heard click on the red star, they didn't know if the preceding sentence was click on the blue star or click on the blue circle or what, right? So that means that it really is more about whether you perceive a contrastive accent rather than any expectation as to like, well, in this context, it would have been natural to have one. And the raters did this in randomized order. So all subjects and trials were kind of mixed in there. And I bring this up because later on, when we take a peek at order effects, it does seem to be that any order effects are from the order in which participants kind of went through the experiment rather than how the raters were responding and whether that was changing anything. So this kind of impressionistic judgments were kind of inspired by the rapid prosody transcriptions that's been proposed and I think pretty effectively validated in some work by Jennifer Cole and others, and also by some of the previous studies that I discussed on prosodic priming, which they did a similar thing. And so firstly, and to kind of orient you as to how I'm going to be showing the results, I'll show you the predictions, or at least what I expected would happen, could happen. So here on the y-axis, we have the proportion of accented productions. And then on the x-axis, we have the context manipulation, the neutral context on the left, the modifier focused on the right. And then we have the prime manipulation represented by the different colors. And what I thought would happen is that, well, in the neutral context, it felt like it would be pretty awkward to include a contrastive accent. So I thought, well, the context doesn't support it. And so even if you just heard a contrastive accent, if there's no real reason to kind of convey contrastive focus or contrastive information, then people aren't really going to produce a contrastive accent, right? So I thought that overall, the rates of contrastive accents would be pretty low in that context, and that the priming wouldn't make much of a difference. And I thought maybe this was kind of what was happening with some of those previous studies. Whereas on the modifier focus condition, well, now you're kind of mentioning the same shape with a different color. It makes sense to contrast it. It could be informative. So people are going to be more likely to produce contrastive accents. And if you were just exposed to a production of a contrastive accent, that may boost the likelihood higher, right? I'll confess that I didn't, I didn't have strong expectations about 40% here, 60% here, nothing like that, but just relatively, this was the kind of pattern that I thought we would observe. I'll show you what we actually observed. Same type of graph, so you're already oriented. But this is what we saw. And I'll note that there's a change in the y-axis here, at least in terms of the scale, right? So we see something that's, I think, similar to what we predicted, but with some notable differences, right? So firstly, as a kind of easy pattern, we do see a difference, main effect between the contexts. So people were much more likely to produce a contrastive accent in this modifier focus context than in the neutral context. That's good. That was the goal. Nevertheless, we also see a main effect of prime, which was surprising to me. So what I was expecting was really an interaction. I thought we'd see a priming effect in this context, but not really in this neutral context. We get a main effect instead. So priming looks like it just boosted the likelihood that someone was going to produce a contrastive accent regardless of the context. And in fact, I've done some post-hoc analyses, and it looks like the priming effect is mainly driven by this neutral condition. So it looks like priming is making it more likely that people produce contrastive accents, especially in this context where it would be, in my opinion, kind of awkward to do so. Still numerically, we see that trend for the modifier focus condition, but that effect looks a bit weaker there. So I've been thinking, what's going on here? What does that tell us? It's a little bit surprising to me, at least. So on the plus side, I think we do see some evidence that the production of contrastive accents can be primed through recent exposure. And as far as I know, this is some of the first evidence to show it. But we see this unexpected pattern where the main effect of prime was there instead of this interaction. And so there's a question as to why, right? Especially, if exposure to a contrastive accent makes it more likely that you include that, even if in a context that doesn't make sense, like why would those previous studies not find it then? And so I have some ideas as to some things that may be happening here, although I'm happy to hear suggestions, thoughts, and recommendations. But here's what I think is happening. So I think there's two things. Firstly, I think that the contrastive accent production in the modifier focus context is, or at least maybe, at a kind of ceiling. In this case, contrastive accent production, it seems to be around 50%. 50% is nowhere near 100%, but of course, in this case, it's not mandatory to include a contrastive accent, and so maybe it's just hard to push the rates of contrastive accent production, at least in this study, much higher than 50%. I will say that I have observed a lot of variability between subjects in this. There's some subjects that are very ready to produce contrastive accents, some that are very hesitant, some that don't ever at all, etc. And so given that, it wasn't too surprising that averaging out things were around 50%. But I think that's part of what's happening. More, I think, informatively, especially as to that neutral context, I think part of what's going on is that yes, producing a contrastive accent in the neutral condition seems infelicitous or awkward in the context of one trial, but of course, people are doing this a lot. They're doing 60 trials over and over again, and we don't really have that many different shapes and colors that we're using. And so I think one thing that may be happening is that, well, in the context of one trial, that's very awkward, but if you kind of expand the context a little bit to like the preceding trial or maybe a couple trials ago, it may not be that awkward to say like, oh, click on the red star when a couple trials ago you referred to a blue star, or maybe the recording you heard referred to a yellow star or something like that, right? So there are more fine-grained ways to look at this. I'm still kind of exploring the possibility, but as a kind of first glance, I think some order effects may shed some light on this. And so I'll show you some results. This is the same data. It's just that now I've kind of split things up in terms of what quarter of the experiment these data are coming from. So here, the first quarter, the first 15 trials on average, second 15 trials, third 15, the last 15 trials, etc. I'll note that now context is represented by the different lines. So the solid line for the modifier focus and the dash slash dotted line for the neutral condition. We see a couple of things. I mean, there's some patterns here that I'm hesitant to read a lot into because things are kind of crossing over. But I think the main patterns that I observe is firstly that overall there's a decrease, at least a slight decrease in contrastive accent production. And I think that's either fatigue or boredom of doing all these, or maybe not wanting to kind of cooperate as much. So something maybe more methodological for me to keep in mind for future studies, that people seem less likely to produce these as the experiment goes on. But I think there is an interesting pattern, especially in the neutral. Can you all see my mouse? Like if I kind of, okay, good. So for these bottom lines, for the neutral context, I think there is something where before that kind of exhaustion or that decrease sets in, there is a kind of increase where people are initially kind of, as the experiment progresses, they're becoming more likely to include a contrastive accent, right? Now, crucially, that we still see this big difference where priming seems to be pushing that probability up, but I think there's at least some slight evidence suggesting that maybe what's happening is that, well, as people get more and more exposures, more familiarity with all the shapes and colors, it becomes less awkward to include a contrastive accent because it may not be as infelicitous as I initially thought or kind of presented it as. So I think we are seeing some patterns that are more complex than when I initially expected. What's new with with any production study or any prosody study for that matter. But nevertheless, I do think this is a promising first step, finding some compelling evidence that prosodic productions are primable. And so I want to go back to what do we learn from this? So what if prosody is primable? Like, and from the evidence that we have so far, like, what can we start thinking about in terms of what that says about these mental representations that allow us to use prosody in production? And so I think there's a couple of things, especially when paired up with some of the previous studies. So I think one thing we can say is that, well, prosodic priming, I don't think would occur at a purely phonetic level, right? I think one possibility is that, well, maybe you hear someone say something and you're more likely to kind of follow their intonation pattern or kind of imitate the kind of skeleton of the utterance, so to speak, right? I don't think that's something that we observe. I think that's something that, if it were the case, I think the previous studies that have explored it would have seen evidence for priming, and yet we do not. in terms of a more kind of impressionistic piece of evidence, is that we actually see quite a large variability in how our participants produced their contrastive accents. I mean, these were people from, they were all English speakers, fluent English speakers, but they had different backgrounds, different dialects, etc. And so it doesn't seem like they're just matching kind of the like what they just heard, right? It does seem like they're kind of producing it in their own way. So I think if prosodic priming is a thing, it happens at a more abstract level. Maybe what's being primed is not really like a specific contour per se, but more the meaning of like, oh, focus, and maybe specifically contrastive focus, right? Also, there seems to be a need for enough of a supportive context to observe prosodic priming. And I think this is tied to why I think that what's being primed is focus rather than maybe like the specific phonetic form or phonological form, right? So I think in order to observe prosodic priming, there kind of needs to be a context where that's information that the speaker would want to convey, or at least could convey, right? So again, this is a very general first first step, I think. I think there's a lot of ways or a lot of directions that we can take this in. Methodologically, I think some of the future studies that I'm running will use fewer trials, maybe trying to kind of minimize some of the messiness of some of the order effects and how things change, unless that's something that we're explicitly interested in. But I think we can start already asking some questions that will be revealing about the mental representations for prosody. So for example, how specific is prosodic priming, right? You can ask, would exposure to a contrastive accent on a modifier make one more likely to produce a felicitous accent on the noun, right? So if you click on the red star, and now you produce a instruction that mentions the green square and the green circle, right? Would that be effective? Or does it seem like a highly specific thing where maybe prosodic priming is kind of tied to specific roles or specific locations, right? And you can't really kind of abstract from that, right? That's an ongoing study. Hopefully we'll find out. And also moving past just contrastive accents to other prosodic phenomena like intonational boundaries. Can those be primed in similar ways, right? So those are some immediate directions that I'm currently taking this into. Okay. So as an interim summary, I think we find some promising evidence that prosody is maybe not that different from some other levels of linguistic representation. That doesn't mean it's not special. It is to me. But at the very least, some of these tools we can apply, and we can hopefully learn more nuanced information about how we represent these from these methods. I think maybe, are there any questions about what I've presented so far that anyone would like to ask before I move on to something totally different?
I have some questions, but I think I'll keep mine for.
Okay, yeah,
Yeah.
totally. Yeah, okay.
I had been wondering about that third context that you were talking about, and its obvious relationship to the intonational boundary at the end of the tokens, right? And I've been wondering whether it might be an intermediate case between the other two contexts, but I guess I'm anticipating those future studies. Or
Yeah.
have you looked at any of that data yet?
Not yet. So those are,
Okay.
we're running them, but yeah, I'm excited to find out. I mean, I think I kind of hope I mean, I think it's, I came into this thinking that it's going to be interesting either way, right? We either find more evidence that it seems impervious to priming, maybe a little disappointing, but at least, there would be some consensus. But then if we find some evidence, I was kind of hoping that's like, well, okay, then we can keep pushing it and keep, use it as a way to learn more. And so I'm excited to do that, and hopefully we'll keep doing that. Yeah, thank you. All right. So I'll continue. This second part is a little bit shorter, and is on something, I don't know, but I say completely different, but maybe it isn't. This second part is talking about phonological encoding. So still what are the processes through which we assign a kind of form to our message, but in this case, specifically how we select the appropriate phonemes for the words that we want to say. And in this case, I'm curious about what the process is like, and I'm not the first to look into this, and I'm kind of following up on a good number of studies, but this is highly related to the study by Sevald and Dell from 1994, where they proposed that this process of, say, you know what word you want to say, and now you have to turn it into sounds. And so you have to select the appropriate phonemes in order to create an articulatory plan that would make it a reality. They propose that this is a process that happens in serial order, that the phonemes are selected in order and then sequenced in order to produce an utterance. And their study, what they did, it was a very simple study. People just had to say 2 words back and forth as fast as possible, as many times as possible, right? So something like if the words are pin and pick, they're just saying pin, pick, pin, pick, pin, pick as fast as possible. And they found that speakers were slower to complete productions of these words when the words shared initial phonemes, such as the case of pin, pick, than when the phonemes were shared finally, like in the case of tick, pick. Right? So in that case, I think participants said 8 seconds, and it's like how many words can you say complete, right? And so they took this as evidence that, oh, when we select phonemes, when we're producing these words, you're selecting these phonemes in order. And this is kind of what they propose, right? So this is a figure from their paper. And so they propose that the reason why it seems to take longer for people to kind of produce more completions of these words when the overlap is initial is because of some interference in the process. So say that you want to say pin and you just said pick, right? This is like an old school neural network model where you have word representations, right? Pin and pick. Right now you're trying to say pin, and so the task of this model is to select the appropriate phonemes to do so, right? So you want to say pin, the first phoneme to be selected should be p, right? And so that's would be accurate, but because you've selected p, that's going to send some activation to the words that kind of fit with that information, right? So, oh, pin is going to get some extra activation because you've selected a phoneme that fits well with it, but pick is also a word that you've said recently, you've accessed recently, and it also fits in with this selection that you've made, which is this p in onset position, right? So the word pick is going to receive a little bit of activation from that because it fits with what you've said so far. Right? And now you're still trying to say pin. You select this second phoneme, right? And once again, that's, it fits with pin, but it fits with pick, right? And so pick is going to get some feedback activation from that as well, right? And by now, now pick has gotten activation because it was recently accessed and because everything you've said so far in terms, or at least everything you've selected so far in terms of these phonemes fits pretty well with pick, even though what you're trying to say is pin, right? So now for the last step, you're trying to say pin, you're trying to select the phoneme but given that pick has received enough activation by now, k is going to seem pretty tempting. It's going to be competing pretty strongly because it fits pretty well with what you've done so far, right? And so that may introduce some interference that the system may need some extra time to kind of recover from, or at least to kind of select the appropriate phoneme. Now this doesn't, or this isn't expected to happen in a case where, say, you're trying to say tick after saying pick, right? Even though there's still the same amount of overlap because, well, when you select the first phoneme, say t, right? Well, that's already disambiguated, right? And now everything else, even if it does fit with this competitor pick, right? Like right? Any activation you get from pick is now going to fit nicely with the selections you have to make to kind of complete a production of tick, right? So even if pick activates or activates k, well, those are the sounds that you're going to select anyway, so it doesn't really create interference, right? So that's the initial hypothesis, at least. I hope that kind of makes sense. Now, since Sevald and Dell, in some studies that, and some of them I've been involved in, we've seen that this pattern, at least this effect, seems to generalize to a good number of contexts. So it's not necessary that you're saying pick, pin, pick, pin. It actually generalizes to more naturalistic sentences, so that if someone, say you say, the beetle shrinks and then the beaker flashes, even though now you've got separate sentences, separate or different words that are kind of intervening the two words, we still see that lengthening of the second word, right? So beaker, after having said beetle, seems to be longer than beaker after having said parrot. A few other studies, there's some interesting patterns that I won't go too much into, but that I think shed some interesting light into this process. So the process seems to be sensitive to metrical similarity. So candle after saying candy, it seems to, if our interpretation is correct, result in more interference than candle after having said like canteen. The effect also seems to happen if the speaker has only heard the kind of overlapping word. So if you hear beaker and now you have to say beetle, you still get some lengthening. So that's from the study that I was involved in. Most relevant for the work that I'm going to be showing is a computational model that I worked on some years ago when I was in grad school, where the model predicted which words should be lengthened given other words that the model was producing. And it predicted also where within a word the lengthening should be observed. And this was specifically in some multisyllabic words where the whole syllables were shared. Right? And so the present study is kind of following up on this. I'm revisiting this model just because I was curious about what else we could learn from it. And specifically in this case, I was curious about what other information may be relevant to this phonological encoding process, right? And part of what's informing my approach here is this kind of motivation I have, I guess, that's to see what patterns in our speech can be explained as artifacts of very low-level type of processes, right? In a way, this is kind of like spiritually the opposite of the rational approach, right? Where people kind of assume that, well, let's assume an optimal process and see what that predicts. This is almost the opposite. It's like, let's see what a very simple little toy would predict and see if it actually matches what people do, right? So I'll briefly tell you about the model and then tell you about some of the predictions it makes. I apologize, like I don't know if the predictions bear out. We're currently running a study that will either show that the model is right or wrong. I'm excited to find out either way, right? But I'm excited about the predictions at the very least, right? So the model is a very small, I would say simplistic neural network of a serial encoding process. It's not recent. It's not a big fancy LLM or ChatGPT or anything like that. It's not very powerful, really. I mean, it's stupid, to be honest. It's a toy, right? But I think that's to its strength, at least. That's why I'm interested in these, because it's so simple that any patterns we observe, we can say with pretty high confidence, like why it's happening, right? It's probably because of this serial encoding process or sequencing process. So this is a simple recurrent network, often abbreviated as SRN. Again, not recent. This has been around since the 80s at least. But crucially, it's a neural network that can be trained to represent serial order. Are people familiar with SRNs? Okay, I'll give you my kind of quick and dirty summary of how they work. So let's say that you've got a neural network like this one, and let's say that its job is to kind of produce words. So you have this representation where you have these nodes that may be on or off, and let's imagine that that's the meaning of a word. Let's say it's the word cat, right? The meaning of the word cat, whatever that may be, right? And the model is supposed to produce the sounds that are appropriate to the meaning of cat, presumably k, a, t, right? So you've got this input layer. It's connected to some kind of hidden layer, right? And then from that hidden layer, it's connected to some representations of, let's say, some individual phonemes, right? Now, with a model like this, you could train it to kind of give you an output that looks like it represents the sounds for cat, right? So you could have this meaning, and you could have it turn on the nodes for k, a, and t, right? At the same time. But the problem is that there's not really any way to keep track of order or the structure of, or how those are related to each other, right? So for example, if this is the way you do things, you don't really have a way from telling apart the output cat from the output tack, right? Because the same nodes would be on, the same nodes would be off, and there's nothing really that's encoding position or anything like that. So there's many ways in which you can encode that. You could have like separate phonemes for onsets, vowels, codas. That's been done in the past, etc. Although there's some implications that we may not want, but it's a possibility. But the SRN is it's a simple tweak, but I think it's a very sophisticated one, where what it does is it takes one of its layers and it copies it, and then the next time it runs, it uses that copy of itself at a previous state as part of its new input, right? So then in this case, let's say that this is the meaning for cat, and now the model is supposed to output the phonemes for cat. It could first activate k, and then the model copies its representations and it kind of feeds them back onto itself so that it knows like, well, I want to say the word cat and I just say produce the sound k. So given that that's my input, I know that now what I want to output is right? And now it does the same thing. And now it has enough context that it remembers kind of what it just produced. And so it can produce a new thing from nominally the same input, right? Okay. I hope that makes sense. It's not super crucial, but that's kind of the nitty-gritty, so to speak, of what's going on. So the model that I'm presenting, it has the task which is to produce words. words, right? I mean, these are very impoverished representations, but that's kind of how I'm thinking about this. So it takes a distributed semantic representation as an input, and then it produces a string of phoneme representations one by one as an output. And we're interested in, well, when is a word easy for the model to produce? When is it hard? So we trained the model to produce 2 words. So again, these are very silly models. Each model just has a vocabulary of 2 words. But the 2 words may be related to each other in different ways. So they can be similar in their outputs, the kind of sequence that they're expected to output, which in the context of this model, we're seeing as analogous to having phonological overlap. They have to kind of pick the right outputs in the right order, right? Or they can be similar in their inputs, which may be analogous to having some kind of semantic similarity, maybe. Oh, the meanings are similar, but the outputs are totally different from each other. And they can be similar in both, so they could be both semantically similar or phonologically similar, or it can be totally unrelated, which would be a nice control. So we kind of instantiate these vocabularies as so, and so this is a little bit ugly, but you can imagine that each one is a node that is on, each 0 is a node that is off. And so if we want phonological overlap in this model, well, we have these input representations that are totally different from each other. But then the sequence of outputs that they have to produce, in the first step, they produce the same vector. At the second step, they produce the same vector. And then at the third step, they produce a different vector. They kind of diverge at the last step, right? So that's our mock kind of phonological overlap, saying pick and then saying pin. For semantic overlap, we have something similar, but at a different stage. So the inputs are now overlapping. Not completely the same, but very similar. But now the output representations are very different. They don't really share the same nodes that need to be on at any stage. We have a mixed overlap condition that's just done by mashing those two. So now both the input representations and the output representations are similar. And then we have a control condition, no overlap at either the input or the output, right? And so we're interested in this case in looking at the loss, or kind of like when the model outputs something, how far away is it from what we would have expected, right? And we're using that as a kind of measure of when we expect difficulty, and therefore when we expect a speaker to lengthen a word. So I'll show you the model predictions. So here on the y-axis is the loss. In this case, it's a very simple. This is just mean squared error. So kind of on average, how far away was the actual output from the idealized expected output. Higher means further away, and therefore maybe more interference, or at least harder for the model to produce the word. We see the control condition is a good kind of baseline. In the case where there was what I call semantic overlap, or at least similarity in the inputs, we don't really see much of a difference, right? Numerically, it might be, it might predict a little bit of a facilitation, but I just wouldn't read much into that. It looks kind of the same, right? I didn't know that we had data about this, but funnily enough, when I showed this to my collaborator, Cass Jacobs, they reminded me that they had some data that actually looked at this, and it kind of meshes pretty well. So that was exciting. I was unaware when I did this. For the phonological overlap, we see what's expected and what we found before, which is that, oh, that seems to introduce some interference with the model. It makes it harder for the model to produce these. Interestingly, and I think this is a novel prediction for these models, is that in the mixed condition, the case where there's both overlap in the inputs and the outputs, it finds it extra difficult, so to speak. So like the model has an even harder time to kind of complete these productions than when in the purely phonological overlap condition, even though semantic overlap on its own doesn't really make much of a difference. So kind of like an interesting interaction there that we're curious to find out if we see. Unfortunately, we don't know yet if this bears out. So this is, I think, on the one hand, nice that it's like, well, we've got a very specific prediction here. We're putting it to the test and see if that happens. And so the way that we're putting it to the test is kind of following those previous studies where people kind of describe events on a screen, and we can manipulate the relationship between the words, similar to how we did with the model, right? So you can have the leopard flashes and what's the length or the duration of leopard after having just produced letter, where there's phonological overlap but not much semantic, or the tiger shrinks, the leopard flashes, where there's some semantic similarity but not much phonological, or a mixed condition like the lion shrinks, the leopard flashes, or a control, right? The hammer shrinks, the leopard flashes. So we're curious to see if we see durations kind of pattern out in the same way that our model predicts. I don't know. I think it's a bit of a long shot, but I think it'd be really cool if it happens. I'm excited to see what we find, whether the model is right or wrong, right? I think if the behavioral data matches the model predictions, I would take that as at least some evidence that these durational patterns, or at least can be to some degree explained by these kind of low-level artifacts of just kind of mapping inputs to kind of sequential outputs. And so I think that's why it's a strength that the model is so silly. Like you may say like, well, this is nothing like word production. Like we know that there's a bunch of other stuff going on and this can't account for all of that. And I completely agree, right? But I think that's why like if the model is right, it's would be exciting to see like, well, it's probably just from these silly overlap mappings that even this model can face, right? That said, there's still many open questions to explore in this area. We have a bunch of other studies that are still using the same kind of paradigm to look at some more nuanced questions. Happy to talk about those. But for now, I'll just wrap up. And so I know I've presented some pretty different lines of studies, but I hope that they serve as a kind of example or multiple examples into how what an utterance sounds like can give us some clues, or at least some kind of way of getting into the processes that speakers are using to give form to their message. We've seen that speakers are more likely to produce contrastive accents after having recently heard one, so some evidence for production priming and prosody. And we've seen that lengthening of words with similar initial phonemes may be because of difficulty faced by the phonological encoding process, or at least a very simple sequential encoding process. We'll see if that prediction bears out. So I'm excited to find out. But other than that, I'd just like to thank all the lab members, my collaborators, these are PhD students and a lot of undergrad students that have helped with the running of these studies. And thanks all of you for your attention and for having me here.
Yeah, thank you, Anders. This is really cool. We have time for questions. As usual, we give presents to students. You can both type them in the chat, both Andres and I can keep an eye on them. But I also think you can just raise your hands and jump into it. And Andres, I'll let you, I can keep an eye on things, but if you see people with hands raised, feel free. So go ahead with your question, folks, if you have any. I'm gonna start just so that I give people time to type things in case they want to type.
Go for it.
And so I have a double kind of questions that is both unformed, but so one they're both related mostly to your prosody priming questions. And so one is you were making these points about having less trials. And even in the syntactic priming literature, like Grosha Prasad's dissertation has shown that trial repetition is a problem to see these kind of priming effects. And so I think she makes these kind of strong points about these kind of trade-offs between we want enough data, but priming is a problem. Repetitions of are a problem in priming. And so I'm wondering how you're thinking about this balance. And so relatedly, in terms of things that maybe might make prosodic priming hard to detect, when you think about intonational boundaries, this line up between intonational boundaries and kind of constituency boundaries, whether you have thought about, or maybe part of the reason is that this misalignment with constituency boundaries might make the intonational boundaries implausible, but in the other case, the prosodic priming might be masked by the syntactic priming in a sense.
Yeah. These are great questions. So I'll start with the first one. So the methodological kind of point and thinking about this balance between, on the one hand, we'd love to run a bunch of trials like that. Oftentimes that's the best way to kind of increase power and given that this has been elusive, we would like a lot of power. On the other hand, it may work against us. And so, yeah, I started out worrying about that because I'm currently getting some studies set up that use not quite half, but almost half of the number of trials. So going from 60 trials to I don't remember, 32, I think, where we may still see order effects, but maybe it won't be as drastic as, like as 60 trials or something like that. As a kind of test to see if we would still be able to detect things, I did do some kind of exploratory kind of post hoc analyses with the data that we have from this study and just seeing kind of like, well, what if we just look at the first half of, the first two quarters, like do effects show up? And they did, which is, I think, what should we say? It puts my mind a little bit at ease, although there's still a little bit of wiggle room. The other thing is that I'm lucky that we have this big subject pool that makes it a little bit easier to recruit students, and our students here are pretty diverse, at least compared to some departments I've been in, and so we we get like a good amount of representation that we can see kind of like, okay, like is the effect generalizing? Is it super specific or anything like that? So yeah, it's been on my mind a lot, but hopefully we can make this, or at least find this in cases where we can drastically reduce the number of trials. The second question, what was it?
Oh, I was just wondering about whether
Oh, the intonational boundaries.
Yeah.
Yes. So I think this is partially why I wanted to start with contrastive focus, where it seems a little bit easier to kind of find a situation where, it's optional, it doesn't totally change the meaning, but it'd be informative. So that kind of balance, right? As opposed to like a hugely dispreferred option versus not, right? Let me think. I was toying around with some examples that were like, you could include a boundary, but it's not it's not hugely informative as to kind of like, say, the syntactic structure, or at least in terms of like disambiguating sentences or something like that, right? I think that's one thing that the Tooley et al. Papers did, was that they relied on ambiguous sentences, and I think in that case you were kind of hoping that the prosodic priming would be enough that you'd want to convey this meaning of the sentence rather than that meaning of the sentence. And I think that's maybe a lot to ask of a prosodic priming. So I had examples of like, following a similar type of paradigm where it's like, oh, like put the red square next to the blue circle or something like that, right? Where it doesn't have to be there, but it could be there. And so maybe that's, I was kind of leaning to something like that, at least as a starter, to see kind of like, well, do people follow that kind of pacing or structure? Does it seem like people are producing boundaries? And then if we see that, then toying around with more nuance, then which is where I'd like to go, because one of the things I'm interested in is about how all these things kind of come together, right? And prosody does come together with a lot of things. So I think these are pretty simple, but it's just because these are first steps. And my goal is really like, if this works, like let's let's see what, where we can take it. But yeah. Yeah, thank you for the question. Oh, yes, Caleb.
Hi. I was first of all, I liked the model that you used at the second part.
Oh.
I'm a big fan of simple models, so
Yeah,
I
thank
was
you. Me
you don't
too.
have to defend that to me, but I was curious though. You said you had to just predict what out of two, where it was like had two options of words to produce.
Yeah.
And I'm wondering if you used a more realistic sized lexicon with the exact same simple model, if it would give you the same predictions or if it would give you a totally different pattern of predictions. It seems that that could be something you could potentially check before you get the responses back from, or the results back from humans.
Yeah,
See whether-
absolutely. Yeah. Well, I mean, we'll have time because they'll need to be transcribed. So we have a good period to do work there. Yes. So I actually I have explored that, but there's, with modeling, there's often so many ways that you can explore a single thing. I have played around with that. I With the kind of playing around that I had made, I was it's messy. It was messy. And part of the reason why was because the way I had done it, it it's still not like a realistic lexicon. It just had way more words than two. So I don't remember how many, but it was like a few dozen arbitrary words that like could share different, like varying degrees of overlap with other words, like either an input or an output. And so then where I kind of faced a kind of block, or where I kind of was having trouble kind of making sense of it, is that then you have so many possible relationships, right? Where it's like, well, you have one word that, say, has some sort of similarity to like 8 other words, right? Or you have two words that are very similar to each other, and all these things. And so I wasn't finding many meaningful patterns there, but just because, or I suspect largely because of the first stab that I took at it. But I'm curious to keep playing around with kind of more realistic lexicons and more types of relationships between them. Cool. Thank you.
There is a question in the chat, but I do want to mention first that because of how our Zoom is set up, is gonna kick us out at 5 precisely. So if that happens, it's not because we closed the Zoom.
Yeah,
It's just we
okay.
set it up in this way. But so Randa in the chat was asking whether you have an hypothesis on how your prosody data would integrate with larger discourse analysis.
Let me think. So I think I have a question as to integrate in this case, like and what like how you're thinking about that. But yes, at least abstractly, I do think that the discourse is going to be an important part of this, right? In fact, I think part of why I thought that like the initial studies that were looking at focus and whether they were primed and stuff, part of what was going on was that there wasn't enough of a discourse context to to kind of facilitate or at least to make it informative to include this prosodic information. And so I think I can say it's that it's an important part of the process, and I think it's part of the relevant information that goes into like whether people, or at least whether we can kind of nudge around like the likelihood that people produce these things, right? I hope that gets to the question. Yes, Ed. Oh, you're muted currently.
Am I muted still?
You're good.
Okay, good. I have a little bit of a question about the literature, which I have not been following for a bunch of years.
Yeah.
But in the early 90s, there was some work about these models. So I'm thinking about like Marcus et al.'s critiques concerning Bates and Ellman, and concerns about, I agree with Caleb, what Caleb said. I love simple models.
Yeah.
And I'd much prefer, and so I like that part very much.
Yeah.
But the question back then was, are these models truly, or one of the questions was, are these models truly simple, or are they hiding a certain amount of complexity from, you know, from the functionality that they encode. So, I mean, has the literature continued to explore that, or what might you say about that?
Yeah, that's a good question. So, I don't know to what extent there was consensus in terms of like, oh, if like how far the literature pursued and if they concluded anything. I will say that I think I agree to an extent. Like I think relatively this is a simple model, and but I think I'm very ready to agree that there's a little bit more complexity going on than meets the eye, and I think there's been some kind of computational / experimental results that show these kinds of things. So like when I presented just the kind of like quick, dirty explanation of an SRN, right?
Yeah.
You'd think that it's like, okay, so it's a model and it can just keep track of its immediate previous step or something like that, right?
Right.
But I remember some studies that shared that actually the models somewhat puzzlingly at first seem to be able to keep track of wider windows, so that if it's trained to produce like segments, and it may be accurate at kind of like including a at the end of something that some words ago was, you know, should have been clear that it was plural or something like that, even though it's not current. And so and the way that at least I've always understood that it can do that is that every time it loops, there's always a little bit of a signature, right? Because it's like, well, any, you know, you may think like, oh, it's the immediate previous step, but it's actually like, well, it's a representation of the previous step based on how it got there from the preceding steps, so to speak. So it kind of does pass along a little bit of previous steps, right? So some of that may be going on. Although in this case, I think that there's that these are so small and everything that there's not a ton of space to be complex. And I will say I did experiment a lot with, there's some things that are a little bit you know, kind of like you play around to see what works. And sometimes I'm always scared as to like if any of those choices are the reason why something works. So for example, like how many nodes are in the hidden layer, and like is that part of what? So I played around with that and manipulated that, and it didn't seem to make a difference until I had enough there that it was probably just memorizing like everything just by assigning it to one. So I kept these with like 3 nodes, 5 nodes, and 7 nodes, and in that case the patterns were the same. So
Great.
great, thank you.
We're going to get cut off. So on behalf of everyone, I say thanks. This was a great talk.
Great, thank you very much. And y'all have been a great audience. I really enjoyed this. And send me an email if you wanted to ask a question that you didn't get to. Happy to talk. We owe each other some meetings.
Thank you for joining us, Andres, and for staying on so late into your evening.
Oh,
So,
no, absolutely. No, this has been fun. Thank you so much for listening, and
very good night.
take care, y'all.
Bye.
See ya.